Hey, we have here to another integral. This one's from MIT 2017, problem 12. We've got the integral from 0 to 1 of 1 over square root x times 1 minus x dx. So for this one here, I got this in the comments from Alatea1. He had a different way to do this. In the first video on this, I did this one using beta function, and he had a way to do this without using beta function at all. I thought that was pretty interesting, so I want to do it that way. So to get started with it, what we'll do is we're just going to do a substitution on this, like a trig substitution, which is not really obvious, which we're going to do x equals sine squared t. The nice thing about that is now we've got something squared inside of the radical. The other thing that's nice with this is if we get a value for this 1 minus x here, we have 1 minus sine squared t, but that's just our identity that gives us cosine squared t, which is also going to clean up nice. And then let's just take this x value here, and we'll take a derivative on this. So the derivative is going to be 2 sine t cos t dt. And then let's just isolate the t value so that we can update our bounds. So if I take a square root on both sides of this, we're going to have square root of x equals sine t, and then arc sine on both sides, so we have t is going to be just arc sine square root of x. So now we'll go ahead with it, just updating our bounds. First, take 1 and plug it in someplace. Where am I plugging it? Oh yeah, we're plugging 1 right here. So we'll have arc sine of 1, that's just going to be pi over 2. And then take 0, arc sine of 0 is just 0. dx is going to be all this stuff, so we have 2 sine t cos t dt. And then actually let's do this part all at once. So for this square root x, 1 minus x, we have our value for x is going to be sine squared t, 1 minus x is going to be cosine squared t. So when we take the square root of this whole thing, we have absolute value sine t cos t. But notice everything's in the first quadrant. Sine and cosine are always positive in the first quadrant. Just drop absolute value on this, and we've got our sine t cos t to put here in the denominator. But then I can cancel sine with sine, cosine with cosine, and we're left just integrating 2. Real easy. Integral this is going to be 2t evaluated from 0 to pi over 2. Plug in 0, that's nothing. Plug in pi over 2. We have 2 times pi over 2. So for my final solution of this, we just get pi. Okay, there you go. Thanks everyone today for watching. Have a good day.